Hi everyone, we are a group from University of Macau. I'm Travis. Today we are going to talk about tide energy. Our presentation is divided into 6 parts. Let's begin with the question, what a tide actually is. Our Earth is rounded by the moon through gravitation. Moon attracts the ocean, that's why there are tides. When the side of the Earth is close to the moon, the gravitational pull is greater and there are higher tides. On the opposite, there are lower tides. Now let's focus on how energy transfers from tides. There are barrages, tidal basins, and turbines in tidal power stations. When there is a high tide, seawater will go into basins through the barrage and waiting for the falling of tide. After the tide fall, the potential energy is larger and the water is finally released when the tide arrives at the lowest position. The potential energy of water pushes the turbine to rotate, which drives the generator to produce electricity. The choice of locations of tidal power stations is significant. A minimum tide range of 3 meters is required, often at bay entrance. A steady foundation is required to make sure that turbine won't be destroyed by high pressures. Before the construction, assessing the return on investment and the benefits of power generation and the analyzing of environmental impact are necessary. There are 2 main forms of tidal power. The tidal current power uses kinetic energy from seawater, which costs less to build. The tidal barrage uses the potential energy of the difference between the high and low tides of the sea, which costs more. Now you may ask, how can we estimate the power density of a tidal stream farm? Here's a simplified example. Assume the efficiency is about 50%. Using formulas given above, we can figure out that there are 2 factors which determine the power of a station. The first is seawater's density. The higher the density, the higher the power. The second is the speed of the tides. The higher the cube of the speed, the higher the power. Now let me briefly introduce the development of tide energy. Scientists found that the world's resource of tide energy from power generation is over 1 billion kilowatts. At the beginning of 20th century, Germany built the world's first tidal power station. In 1967, first commercial tidal station was built by France. In 2016, the largest tidal power generator developed and produced in China built in Zhejiang. Now let's welcome David to introduce the pros and cons of the tide energy.
Now let me introduce the advantages of tide energy. Firstly, tide energy is a kind of clean energy which will not pollute the environment. Tidal power plants will not dismiss any harmful gas and carbon. Secondly, tide energy is a kind of renewable energy. The gravity of the sun and the moon and rotation of the earth cause tides together. The difference in potential energy between high tide and low tide allows tide to generate energy. So as long as the earth exists, tide will exist and tide energy is inexhaustible. Thirdly, tide energy is predictable, controllable, and stable. Tides is a kind of phenomenon that is easy to predict according to some regulations and periods. So it is more easy for us to create energy. And total power generation of tide energy is stable throughout the year and cannot be affected easily by factors like climate. Next, tide energy do not need a large space to create energy, which will not occupy a large amount of land resources. So there is no problems such as population migration and flooding of farmland. This is an outstanding advantage for a place where it has lots of people but inadequate land and near the sea. Otherwise, the operation of tide energy do not need high costs. It is also a kind of economic energy. There are also some disadvantages of tide energy. Firstly, construction of tide energy need large amounts of investments. Tidal power stations are usually built in base. Problems about dredging and construction are difficult to solve, so it needs high level of costs in this period. Secondly, appropriate places is scarce. This kind of power station need to be built in bays with large seawater fluctuations, and graphical conditions also need to be suitable. It's not that easy to find such places. Thirdly, devices that need to be used in utilize tide energy may damage marine life habitat. There are some devices we need to install on the water may negatively impact on survival of marine life. Otherwise, tidal difference can be changed during a period of time, as 1 day or half of a month. So the output of the tide energy is intermittent and may bring inconvenience to users. And next, I want to talk about is how is tide energy affecting the future electricity grid formation. Firstly, tide energy can play a role as supplement of energy sources. This kind of energy can be supplementary with other kind of energy sources like solar energy, wind energy, and so on. Diversification of energy sources can make electricity grid more reliable and stable. Secondly, tide energy can improve the efficiency of energy supply because the tides can be predictable and stable during its period. Using tide energy as the energy source of electricity grid can make the supplement of energy more efficient. Thirdly, tide energy can create opportunities of regional development as tide energy usually need specific sites. Development of tide energy can stimulate the economic development and provide working opportunities in specific places. Otherwise, tide energy can balance the load across electricity grid because the activity of tides is periodic. It can help us manage the load across electricity grid better. At the same time, tide energy can be used in conjunction with energy storage technologies such as water pump energy storage to balance the difference between supply and demand of energy. Now I will make a brief conclusion about my part. All in all, tide energy is a kind of renewable energy with large potential, but there are also some challenges of development and application. As the improvement of technology and recognition of the importance of renewable energy, tide energy can play a crucial role in the formation of electricity grid.
Although the history of using the tidal energy is long, there are still ongoing research in this field. First is the maintenance of turbines. Scientists need to discover a more efficient way against the corrosive nature of seawater and the attachment of marine organisms to power stations and turbines. Meanwhile, an eco-friendly technology like dynamic tidal energy that consider not only the economic benefits, but also the reduction of negative impacts on marine ecosystems is eagerly needed. There are also bottlenecks which lower the spread of tidal energy's using. The scale of power stations is hard to increase because of small installed capacity. As we mentioned before, complicated underwater conditions make it hard to lower the cost of the maintenance of facilities. Last, it's almost impossible to weather tidal range artificially, that is, increasing overall utilization of tidal energy is difficult. Finally, let's make a conclusion. We introduced tide energy from 6 different perspectives, and we believe that you have a primary understanding of tidal energy after our presentation. Our presentation comes to an end. Thank you for your watching.